Hi there. So yesterday we talked about continuous at a point and continuous along an interval. And today our focus is talking about removing these discontinuities. So here's example one. And again, pause and write down the question for yourself. The function f of x is defined, it's given to us, is not defined at x equals plus and minus 2. So let's just talk about why that is. If I were to, let me grab my tool here. If I were to look right in this denominator and I tried to plug in positive 2, 2 squared is 4, 4 minus 4 is 0. I'd be trying to divide by 0, which isn't allowed. It's not defined. Likewise with negative 2. Negative 2 times negative 2 is 4. So 4, again, minus 4 is 0. Not allowed. That function is not defined there. So what value would you assign f of negative 2 to make f of x continuous at that point? So we basically just need to redefine f of x. Okay, we don't like the way it is right now. We need to redefine it. And hopefully after the strategies we practiced a few days ago, something jumps out at you about this f of x function. Notice we can clean this function up just simply by factoring. So I'm going to start in the denominator, x squared minus 4. Two terms, I'm either going GCF or difference of perfect squares. So hopefully you recognize that as just x plus 2 and x minus 2. And the numerator, it looks like one of those guess and check trinomials, but the first thing I'm going to look for is a GCF. And in fact, it has one. I can pull a 6 out of every term first. So I'm going to do that. So I've got x squared plus 3x plus 2. And then I'm going to try to refactor that part. So remember, don't lose that 6. But we can factor this part again, make sure it stays in front. I have to multiply to 2 and add to 3, so I think 2 and 1 are the obvious choices, x and x. This is positive, which tells me they're same, and this means they're both positive. All over my x plus 2 and my x minus 2. And now I can simply just clean that up. I can divide these x plus 2's out. They are identical. And I'm going to redefine this function f of x as 6 times x plus 1 all over x minus 2. Now, the only catch is I still want to make that note that x cannot equal the 2 in this case, because of plus and minus 2, since that was the original problem there. It is not defined at plus and minus 2. All right, so now that we've re-engineered this function, our goal is to figure out what f of negative 2 would be to make this function continuous. So I'm just going to evaluate f of negative 2. I have 6 times negative 2 plus 1 and negative 2 minus 2. So that's going to get me a nice negative 4. Negative 2 plus 1 is negative 1, so I've got negative 6. So I'm going to say that's a nice, easy 3/2. So if I wanted to make this function continuous, f of negative 2 would have to be 3/2. Question 2. We're given h of x, and again, it's defined when x does not equal negative 3. So I just want to stress again, if this was negative 3, negative 3 plus 3 would be 0, and that would make this function undefined. So that's why they're telling you x cannot equal negative 3. And h is continuous for all x values greater than negative 12. They want us to evaluate h of negative 3.